Hello, my name is Andy Connell and you're watching a screencast on Systems Analysis Explained, specifically Chapter 6 on Process Modeling. Now everybody knows that computer systems are made of programs. Well, programs, when they're in abstract analysis and design, are called processes. Processes do only one of four things to data items. They're either creating them, reading them, updating them, or deleting them. It is these four functions, or some combination of these functions, which sum up everything that a computer program can do. We're going to be looking at two ways of modeling processes: flowcharts and structured English, also known as pseudocode. There are other ways of modeling processes, such as decision tables, and they are covered inside the book. To do the four CRUD functions of create, read, update and delete, there are three basic programming constructs. Sequence, where one instruction follows another. Selection, where some kind of decision is made as to what is to be done with the item of data. And finally, iteration, where a function is repeatedly performed until a certain condition is met, and then we carry on. Flowcharts themselves show these three constructs of sequence, selection and iteration, and how they interact with each other to form the whole process. And what we see inside the flowchart is the path that a data item takes through these various functions. Flowcharting is a modeling system, and therefore we have symbols. We start and we finish with the lozenge-shaped symbol. We've got inputs and outputs, IOs if you want, that's a parallelogram. We have the process itself, the particular function, and we have the decision point in the program. Stick all these together and what we get is a flowchart. Flowcharts don't have to model computer systems. Here we have a flowchart modeling the filling up of fuel tank. We start, the input requests that the tank be filled. That results in a function which opens an inlet valve. A question is repeatedly asked that says, is the tank full? If the tank is not full, has a button been pressed? If the tank is not full and no button has been pressed, the process will loop round and continue filling. If at any point the tank fills up, the stop button is pressed, the inlet valve is closed and the process comes to an end. They can be a lot more sophisticated, of course, and they do not, as I've said before, have to relate to computer systems. The longer they go on, of course, you might physically run out of documentation, so we use things called connectors to carry over diagrams. Here we can see there's a connector at the end of the first column, number 2, which then continues in number 3, for this very useful flowchart of how to make a piece of toast. The second type of model we're going to look at is structured English. Structured English is describing the process using a very logical, consistent, formalized type of English that almost looks like programming code, but it isn't. It aims to get the benefit of a natural spoken language along with the rigor and logic of a programming language. So, if we look at some of the guidelines, structured English statements express their functions in terms of sequence, iteration and selection. The statement should be clear, there should be no confusion involved. Indenting is used, just as in conventional programming, to show where loops sit. The language used must be consistent, and it is always useful to comment the code to explain to the user what is going on. So taking the three constructs of selection, sequence and iteration, if we start first with sequence, here is some code that shows sequence. We read, we perform a function, and then we perform an output. So input, function, output, sequentially. Next, if we look at selection, here we make a decision based on a particular value of a data item. So we have the input. We use an if-else statement to make a decision, and when the if-else statement has concluded, we print an output. Finally, if we look at the third construct of iteration, here is an example of iterative code. Repeat until end of file, up update customer record, end, repeat. Perhaps not a very useful function, update customer record, a very, very vague statement, but it shows the basis of iteration. So if we put this lot together, what I'd like you to do is to pause the video at this point and tell me what this lot's doing. And finally, to conclude, what I've sought to show inside this screencast is the fact that flowcharts and pseudocode both model the same thing. In fact, when you look closely at all the models we've covered inside the series, they all interact with each other and are logically consistent with each other. This is a very, very important aspect of modeling. Each model brings a slightly different view of the system to the forefront. So it's like looking at a model from a slightly different angle. The more angles we look at it, the greater the likelihood that the model is going to be correct. But the important thing is they are all mutually supportive and do not contradict each other. That concludes the screencast. Thank you for watching.